So in my previous class, I told you about the Dobrina's classification of elements into triads. 3 triads he could classify, and each triad consisted of 3 elements actually. And what he did, he arranged those elements in the order of increasing atomic masses. And he got these 3 triads which had similar properties. In the similar manner, another scientist, actually Newland, okay, he actually postulated another law. He introduced another law which is called as the law of octaves, okay. According to him, what he did, he also did the same thing. He also found out, said that there is a relationship between the atomic masses of the elements as well as their properties, chemical and physical properties. So what he did, he also arranged all the elements in the order of increasing atomic masses, and he found out one peculiar thing or one strange thing about the elements actually. He found out that the properties of the first element and the 8th element, okay, they were similar. That means the 8th element, it's like a repetition of the properties of the first element. So 8th element, octave, octa means 8th. So it's a law of octaves, means like in the octave of music, we have sa, re, ga, ma, pa, da, ni, sa. Again sa is there, isn't it? So the first sa and the 8th sa are similar. So in the similar manner, he also said the same thing. So it's the law of octaves. That means the first element and the 8th element, they both have similar properties. So they can be grouped in one group, he said. So okay, if you see, if you take a look at his classification, if you take lithium as the first element, for example, if you take lithium, if you start from lithium, then this is the first element, second, third, fourth, fifth, sixth, seventh and 8th. What is the 8th element here? Sodium. So lithium and sodium both are, this is the first element, this is the 8th element, and both of them bore similar the resemblances in their physical and chemical properties. So lithium and sodium had similar properties. So what is that? 8th element is a repetition. It's a kind of repetition of the first element. And when this happens, when the elements are arranged in an order of increasing atomic mass, hydrogen, lithium, beryllium, boron, like that, they will be going on arranging in the order of increasing atomic mass, and then they come to this particular conclusion. He came to a conclusion that the 8th element is the repetition of the first element. If you start from sodium again, you will see that the 8th element will be potassium, and the potassium also had similar properties. So that was the law of octaves given by Newland actually. So here if you see that his view of law of octaves, actually it could be positive, it could be correct or accurate only up to calcium only. Only up to calcium this was followed. This law was actually obeyed by the elements. But after calcium, the 8th element was not actually kind of repetition of the first element. It was not following. So that's why this is one of the limitations of the Newland. And he said, and he thought that only 56 elements during his time, 56 elements were discovered, and he said he thought that no more elements will be discovered in the future and only these elements will be present forever. But actually after this, many more elements, as you know that now around 119 elements have been discovered so far. So it is not fitting in his law of octaves. So that he was wrong in those things. And if you carefully observe these 3, lithium, sodium and potassium, it's nothing but, is it reminding you of the Dobrina's triad? Yes, so it's a Dobrina triad. So to some extent up to calcium, this law was fitting nicely, but beyond calcium, this was not fitting well. So that's the main limitation of the Newland's law of octaves. One more limitation is there. In order to just fit into the table, actually in order to prove his law of octaves true, he fitted actually more than one element in a group. If you see this group, cobalt and nickel were put in the same slot, same group actually, but these two had different chemical properties from the other. So So you can see cobalt and nickel, they are different from the rest of the substances or elements in the particular group. So it was not the correct position or placement for nickel and cobalt here. In fact, they were more closely related to iron. They were more closely related to iron. They had similar properties. But still, just to have to show the accuracy of his law, he fitted more than one element in one of the slots, and that too in an irrelevant position. So those are the limitations of Newland's law of octaves. But nevertheless, these two, the Dobryna's triad and the Newland's law of octaves, actually they paved the way for the other scientists to improve. So such is one of such improved or advanced thing is nothing but the Mendeleev's periodic table. So it was much more closer, and it had some points from Dobryna and some particular facts or points from the Newland's law of octaves, and he invented his own Mendeleev's periodic table, which I will be dealing